Okay, so yeah, thanks for having me. I am your substitute Jonathan McDowell for the night. So the I'm gonna tell you a really wild story and then some depressing stuff, and then kind of uh, hopefully motivate some action. Um, yeah, so I like to start my talks by just kind of reminding everybody where we're coming from with this, right? Uh, Astronomy is a truly ancient science, right? We humans have been looking up at the sky, uh, noticing the patterns, using those patterns to make predictions about when to plant foods, when to look for certain foods, now we use those patterns to look for hazardous asteroids and learn about black holes, right? Looking for these patterns in the sky is part of what makes us human, and it's so deeply important. I want to particularly acknowledge the importance this holds for Indigenous people. So I am speaking to you today from Canadian Treaty 4 land, the land of the Nahiawak, Anishinaabeg, Dakota, Lakota, Nakota, and the Métis-Michif Nation. And all of these peoples have very strong connections with watching constellations and the night sky. Um, there's a really great book if you want to learn more about Cree astronomy by Wilfred Buck. I highly recommend this book. There's also a great website, nativeskywatchers.com, has indigenous traditional knowledge of the sky from a whole bunch of different cultures around the world. Really great resource. Um, and we're slowly losing our connection to the night sky, right? um it's so hard to get access to a dark sky, and that's gotten much worse just in the last few years because of LEDs, right? LEDs are great. They provide more light with less energy, but because they're cheap, they're overused, right? So light pollution, urban light pollution has really jumped just in the last few years. I'm really lucky to live in a place where I can drive an hour out of the capital city of the province and have Bortle 2 skies. Like, it is just delightful. In Michigan, it looks a little harder. There are places, right? So anything that's green or blue is even better, is like pretty decent skies. So you can get to decent skies, but you have to work for it. You've got some very big, bright cities around you, but you can get away from it, right? There's this new global source of light pollution that you cannot get away from anywhere on Earth. And this is primarily driven by SpaceX. They're launching batches of 60 satellites at a time into low Earth orbit every few days. There's currently, I hate this part of the talk because it's so much more every time. I just gave this talk 2 weeks ago, and there's almost 100 more than there was 2 weeks ago. Almost 7,000 Starlink satellites in orbit. Two-thirds of all active satellites in orbit are owned by one private company that's owned by one billionaire. And that happened in 5 years, right? It changed very, very quickly. The problem for astronomy is that these satellites reflect sunlight long after the sun has gone down. Um, we've gone through this transition point where it used to, like, I used to look up, like, when is the International Space Station going to fly over? Oh, hi, astronauts, right? But now it's like any time you go outside within a couple hours of sunset or sunrise, there are satellites that you can see. There's no rules about satellite brightness or orbits or launches or really much of anything. It's kind of a free for all right now. The engineers who build these satellites have put very little effort into making them fainter so far. Okay, so why am I here telling you this story right now? I am really lucky to be one of the few professional astronomers who I have access to dark night skies. I live in a place where I can see the Milky Way from my back door, and I love it every day. So I can see these satellites with my eyes, and I also see them in my data from telescopes around the world. This is one of the images from the Canada-France-Hawaii telescope, which I use to try to find new Kuiper Belt objects. This is kind of a raw image, so there's all these vertical streaks that's just bleeding from bright stars. All of the diagonal and horizontal lines are satellites, and the vast majority of those are Starlink satellites. And this is even from a couple of years ago, so it's even worse now. Um, so this situation of having dark skies and seeing these satellites increasing with my eyeballs and in my data made me really wonder, how bad is it going to get? So like a good scientist, I wrote a research paper to try to make a prediction for how much is this going to change my sky. So these are little all sky plots. Each of these, so this is your zenith in the center, northern horizon, eastern horizon, southern horizon. And the dots are satellites that are lit by the sun at a particular time and season. And the color shows you how bright they are. So, right, so magnitudes, so anything that is a smaller number than 6.5 is what you can see from a dark place. So any of these dots that are pink, orange, or yellow are ones that you could see with your eyes. Um, and then, so this is on, let's see, sorry, this is just after it gets dark. So in the evening, this is at midnight, and this is just before it gets light in the morning. And this is on the winter solstice, the equinox, and the summer solstice. So this is for my latitude, latitude 50. And this is for latitude 42, where you guys are, Kalamazoo. So it's not quite as bad, but it's still pretty bad. You'll notice that in the summertime, all night long, there are naked eye visible satellites, a few dozen around midnight. So here's a little animation. Let's see how this shows up. So here's your local time. So this is you're the same latitude as Boston, which is why it says Boston. Um, and so here's your clock time. This is how many satellites are in your sky, and you'll notice all the bright ones are right at zenith, right? So that's where the bright satellites are going to be. So this prediction was made with 65,000 satellites, which is how many satellites Starlink, OneWeb, Amazon Kuiper, and a Chinese company have said that they want to launch. And now I know that's kind of an underestimate, but that's using the real orbits that they have asked for and calibrated to the real brightness of Starlink satellites. So this is not looking good for our skies in the future. This is a plot made by Tony Malama. He's an astronomer who he's done a lot of great work just measuring the brightness of satellites. So here is this apparent magnitude again, right? So I said anything brighter than six, any number smaller than 6.5 is what you can see with your eyes. And so there's this he has put this limit at 6. Anything that's brighter than that is really annoying, basically. And anything that's brighter than this line is going to cause major problems for astronomy research. So these are kind of averages of a whole bunch of different mega constellations, or so these groups of thousands of satellites that are being launched. Starlink is the biggest one right now. Starlink also has some direct-to-cell satellites, which are even bigger. There's these giant, like house-sized satellites that are being launched for direct-to-cell. And then a couple of different Chinese companies and OneWeb. So I ran a simulation because these bluebirds in particular, like they're really big. And the first one that was launched, Blue Walker 3, was measured to be magnitude 1, so as bright as the brightest stars in the sky. So I made a little simulation with 200 of them on the orbits that they have asked for. So this is from Toronto, so just a little bit north of you guys. So even from, downtown Toronto or, a very light polluted city, you'll be able to see the moon, Venus, and a few of these satellites all night long on the summer solstice. So that's really horrifying. I'm not excited about that at all. Um, so I happen to work in the most strongly affected part of astronomy research, wide field imaging, right? So my research is trying to discover new Kuiper Belt objects to learn about how the solar system formed, find out if Planet Nine is real or not. Um, so typically these satellites that are flying through the field of view that are obliterating my Kuiper Belt objects are millions of times brighter than what we're looking for. So this is a serious challenge. Um, so a lot of my science research revolves around trying to understand the biases in Kuiper Belt surveys, right? So hopefully most of you have heard of Planet Nine. So there's this theory that there's another planet out in the outer solar system, really far out from the sun, 10 times the mass of Earth. Um, and the only way that we know that it's there is because these very distant Kuiper Belt objects, the most distant ones that we know about, all seem to be on one side of the solar system, right? So if you look down on the solar system, all of these orbits, they all kind of point in the same direction, right? The problem is that these Kuiper Belt objects, you can basically only find them when they're at the closest part of their orbit. So are all of them on one side of the solar system because they're actually all on one side of the solar system, or is it because we're better at looking in one direction than another? So this is from a paper by Kevin Napier, and so again, looking down on the solar system. So the black circle is the orbit of Neptune. And the red points are these really distant Kuiper Belt objects where they were discovered, right? So you can see, so they're pretty much at their closest point to the sun when they're discovered. And these white points are showing where we have the ability to find them because we've actually pointed telescopes there, right? So you can see we find them where we have looked for them. And that sounds so incredibly obvious, but it's not. It's not like, why did we only look in those basically two different directions, right? This is looking around the solar system. So why did we only look over here and over here? Why didn't we look around the whole solar system? Um, there's some really weird biases built into this. So this is where the Milky Way cuts through the plane of the solar system from our perspective on Earth. So it's really hard to find Kuiper Belt objects there. So we don't even try, right? Like, how do you find a moving fuzzy dot in front of the Milky Way, right? It's really hard. Um, Over here, it's winter on Mauna Kea when you have access to this part of the sky. So nobody gets good data, basically. And over here, this is a weird one. I think it's the Coma cluster that all these cosmologists ask for telescope time. So it's actually really hard to get telescope time just because all the cosmologists want to use the telescopes then. So there's all of these bizarre biases that are built into our ability to find distant Kuiper Belt objects. So all of that is built into this distribution, right? Which is why I don't think Planet Nine is real, because that the only evidence for it is this clustering that is caused by all of these weird biases that are built in. Um, so I'm actually working on a new survey with the Canada, France, Hawaii telescope where so you can see there's these really deep places where we've looked into the solar system. We're trying to look in five different directions. We were going to try to do six, but we lost time. So these little red slices are where we're looking, and the green slices are those really deep places that we've looked. So we're going to try to see if we also see this bias or not. So that survey is ongoing. The problem is that we now have this extra bias of satellite streaks. So just because of we're looking right in the plane of the solar system, right? The ecliptic plane. And at night, the ecliptic plane is lower in the sky in the summertime than in the wintertime, which means that we have more satellite streaks in our summertime data than in our wintertime data. So now we're going to have this other bias built in, and it's changing every week, right? It's getting worse. Um, so this is going to be a hard problem, right? Like we might not ever find out the answer to whether or not Planet Nine is out there because satellites are making it harder for us to find new Kuiper Belt objects and understand our observation biases. So that's kind of the motivation behind a lot of why I've started working more and more on satellite pollution. And so I have become like the go-to person for one of the go-to people to answer questions about what is happening to the night sky. And so I'm not showing you this to brag. I'm showing you this to set up how weird what happened last summer was. So I live in Saskatchewan, right? Like most people haven't even heard of Saskatchewan. I'm talking about all the satellite pollution. So it was really bizarre when I got a call from a reporter who said, "Hey, this farmer thinks he found space junk. He's just, right down, just a little ways down the road from you. Um, is it space junk?" And I thought, no way, this guy's got to be crazy. Yeah, right. Um, and then it was space junk. Uh, so that was like, what? Why is this right near me? And so it's not super close, but I live in a very rural place, right? So if you think about how many houses I drive by to get to this farmer's house, it's like driving a few city blocks in terms of how many houses I pass by, right? So like this is disturbingly close. Um, so how did this happen? How did we get to the point where someone who studies the proliferation of satellites can have space junk fall near their house? So here's some more of the story. Um, this is Axiom Space. So they have private astronaut missions. This is weird stuff. So I'm gonna go out on a limb and guess that nobody who's watching this talk right now is a billionaire. So this is not marketed at you, but this company wants to get billionaires to pay them to give them a joyride to the space station. So I think that they also do, they contract with countries that don't have their own space programs. So in this case, these guys I think are not billionaires, but I'm not totally sure. It's not clear to me. Anyway, so this is the Axiom 3 mission. It launched on January 18th, 2024, just over a year ago. Oh yeah, you should if you're if you're bored later, you should look at their website. It's wild. Um, all of this bizarre language about like come to space and spend all your money and it will totally change everything. It's really weird. Start your mission. I don't know if do billionaires even click on things on websites? I have no idea. But this is what is dropping junk on us on Earth. So this mission returned to Earth safely on February 9th, 2024, almost exactly a year ago. Um, and this was a Falcon, not a Falcon Crew Dragon. So the astronauts sit in this part of the rocket. There is this part called the trunk, the cargo trunk, which attaches underneath where the astronauts sit. And it's unpressurized. They can put big pieces of cargo in it that will go to the space station along with the astronauts. When it's time for the astronauts to re-enter, they only need this part, right? So this part is still attached to the capsule because it went all the way to the space station with them. So they just eject it, and the astronauts land safely, and this big, I don't know, couple ton piece of metal just orbits around for a while and eventually falls. And that's just how it's done in space because it probably won't hit anybody. It's pretty wild that this is okay. Also, SpaceX said that it would burn up completely, so that's another reason that it's supposed to be okay. So this trunk got ejected on February 9th. It orbited around for about 3 weeks, and then it slowly got into a lower and lower altitude orbit due to drag from the atmosphere. And it re-entered on February 26th. So this is this is the original piece of space junk. Barry Sawtruck is the one who found this piece. He found it, like a kilometer into the middle of one of his fields. This is the land of 10,000 acre grain fields, right? So he was checking the fields before starting spring seeding, right? The snow had just melted, end of April, and so he found this big piece of debris out in the middle of his field, a kilometer from the road, so it's not a piece of a car. It probably he deduced that it is not a plane crash because he would have heard about it on the news. So it must be space junk. And he knew that it landed sometime over the winter because it didn't make a divot in the ground. It landed on snow and then the snow melted underneath it. So like a good farmer, to figure out what it was, he started Googling parts numbers that he could find on it, which is great. And so he went to the local media. And eventually they called me because I'm the only research astronomer in the province, and that's how we got connected. So, so when I first got the picture and saw like, oh my gosh, this is actually space junk, I emailed Jonathan McDowell and asked him, so this farmer found space junk. I think it's actually space junk because it looks just like the pieces that were found in Australia a couple of years ago. Is there anything that fell over Saskatchewan in the last 7 months? Because they wouldn't have noticed it until just now. And Jonathan's so great. He has the best public database of launches and reentries, so he is the person to ask. And he just does this in his spare time. So I emailed him. Within 5 minutes, he emailed back and said, "Oh, yep, there was a reentry on February 26th. Crew Dragon trunk. Here's the ground track." Right. So this is the last orbit traced onto the ground, right? So here's Alberta. So if you had been looking south from Calgary on February 26th at just the right time, you would have seen a very messy shooting star as this big giant piece of debris came into the atmosphere and started melting. And the pieces made it all the way over here to just northeast of Regina. So this is supposed to burn up completely. You can see just from looking at it, it has all this like carbon fiber stuff and all of this aluminum honeycomb that like sort of fanned out and slowed it down as it was coming through the atmosphere. So it did not burn up. And this is the plan for everything in low Earth orbit. Everything in low Earth orbit will be killed at the end of its life by burning it up in Earth's atmosphere. And if it doesn't burn up completely, it will make it to the ground. This is actually how everything in low Earth orbit operates. It's pretty wild. Okay, so back to the space junk. What do you do, right? So at this point, I know that there's space junk. This farmer knows there's space junk. A couple of local news outlets know. What do you do with the space junk, right? Who do you tell? Like SpaceX is notorious for not answering anybody. So who do you tell? So my first thought was, well, the Canadian Space Agency, right? I will email a couple of people that I have contacted before, and they both wrote back and said, email SpaceX? I don't know. So like they had no idea. One of the neighbors who found another piece, I guess he called the Transportation Safety Board, right? Because they're the ones who would investigate a plane crash, right? They never got back to him. I finally called the Turn-In Poachers and Polluters hotline and had a hilarious conversation. But yeah, the rural municipality does not want to try to sue SpaceX for littering, so that didn't go anywhere. I know in retrospect, I probably should have called the RCMP and talked to them and had, some kind of law enforcement involvement, but I had no idea, and I'm not totally sure that actually would have helped anything. So, what actually ended up being the most useful thing to do was tiny small town local journalism. So, Ituna, Saskatchewan has a population of 600 people, and they have a local newspaper with one journalist, and she is awesome. She was the one who first believed the farmer's story that he actually found space junk. She wrote about it, and then other bigger news outlets picked it up. So good job, local journalism. Support your local paper. Um, and part of why this is so weird is because they're the only laws that govern things that fall out of orbit are from the Apollo era, the 1968 Outer Space Treaty and the 1972 Space Liability Convention. And the only time that this has been tested before now was back in 1978. The Soviet Union had a satellite with a nuclear reactor on board that exploded over northern Canada and sprayed nuclear waste across the Northwest Territories. There's a fantastic podcast about this by a local Indigenous journalist, Operation Morning Light. I highly encourage you to listen to it. He, goes back and learns about exactly how it was handled by the Canadian government, what happened to the locals, what happened to the RCMP officers who were stationed to sit next to the radioactive waste that they didn't know was radioactive, right? Really wild stuff. But what ended up happening was the Soviet Union paid Canada some piddly amount of money to compensate them for cleanup. It like definitely did not actually cover the cleanup costs, but that is the only legal precedent here. And these laws were written in a time when governments were the only entities launching things into orbit, right? Now, the vast majority of satellites are launched by private companies. So, how does that apply, right? What's crazy is anything that is launched from the United States, the US government is absolutely liable for any damage caused by reentry of those objects. So if that space junk had landed on someone's house in Canada, the US government would have to pay the Canadian government. And it's not at all clear how SpaceX or whoever's house got landed on actually actually meet up, right? It's really wild. But what about junk that doesn't cause any damage, right? So this space junk, hundreds of pounds of it that was recovered by several different farmers in the area. Who has to clean that up? So apparently these guys do. So so I was invited by Barry Sawchuk to get some journalists to come and watch while SpaceX sent a couple of employees to come retrieve the pieces of space junk. And he did that he said to keep SpaceX honest, which is a good idea. So it was so bizarre because so I did feel kind of bad for these guys because they showed up and there were the middle of nowhere, right? There's 10,000-acre grain farms all around this area. And they showed up, and there's a dozen journalists who are suddenly asking them questions, and they didn't even want to say they were from SpaceX at first, which is really weird. But so eventually they said they were from SpaceX, and then they did not answer a single other question. They came and they picked up the pieces of space junk as all of these reporters filmed them. They eventually went into a back room with Barry Sawchuk. They did actually end up giving him a small compensation for retrieval and storage, which he donated to the local skating rink because he's awesome. And then they left. But I did get to try asking them questions, which is great because as someone who studies all of this pollution from SpaceX, it's really nice to actually finally get to ask someone something. But I tried offering them some donuts. They did not answer any questions at all. One of the journalists who was there said, "It's okay, you can answer her questions. You can trust her. She's an astronomer, or she's not a journalist." And I said, "I'm an astronomer," and I'm pretty sure I looked like the Grinch, like with that really creepy smile. So, anyways, they didn't take any donuts and they didn't answer my questions. Um, So what happened next, right? So they took the space junk, they loaded it up in a rented U-Haul, and I hope they took it back to Texas or California or something to study it to find out what went wrong. But I don't know. They could have just dumped it on the side of the road or dumped it in the local dump or right. Crossing the border with space junk. Like I can only imagine how much fun that would be. So yeah. So and they never apologized, right? SpaceX never publicly admitted that this was theirs. NASA publicly admitted that it was SpaceX's, but SpaceX has never said anything publicly about this, which is weird. So yeah, so that's where we are. And right when all of this was happening, another piece was found in North Carolina of the same type of craft, this Crew Dragon trunk, right? So they're dumping pieces of them all over the place. Um, and so these uncontrolled reentries are a standard part of space launches. They're supposed to have a less than 1 in 10,000 casualty risk, which is surprisingly high, really. Um, and there have been more and more big pieces making it to the ground. And Starlink plans to deorbit almost 10,000 satellites per year. Right. So Starlink wants to have an operating capacity of 30,000 to 40,000 satellites. If they all have 5-year lifetimes, as they have said, that's a lot of deorbits. They have said that they burn up completely, but they also said that this big piece that made it to the ground would burn up completely. So I'm not convinced this is a great idea. 1 in 10,000 casualty risk when you're deorbiting that many things, that's not good odds. So I'm quite worried about this. So there's other issues with having so much stuff launched into orbit, right? So this is the number of objects in orbit versus time. Red are abandoned rocket bodies. So these are the really big pieces, like bus-sized pieces that eventually re-enter after the satellites detach. Orange is the payloads, right? You can see exactly where Starlink started because the slope of this line just changes. There's a hockey stick there, right? Trackable fragments is junk, right? You can see a few jumps in junk when collisions and anti-satellite tests have happened. And the total just keeps going up, right? Low Earth orbit is getting very crowded. Another way you can look at this, so this is assuming that the satellites are uniformly distributed in shells, right? Because they're not all at the same altitude, right? They're not sorry. Some altitudes have more satellites than other altitudes. So that means that there are higher density parts of orbit. And if you just assume that they're randomly distributed, you can calculate how often they come within a kilometer of each other, which sounds like a lot, right? Kilometers pretty big, but everything in orbit is traveling at several kilometers per second. So coming within a kilometer is really close. So in Starlink's orbit, if it was a uniform density, which it's not, they have it distributed, so it's not this bad. But there are close approaches happening on average every 30 seconds, which is really terrifying. We know that Starlink does collision avoidance maneuvers many times per day, so this isn't that far off. But so low Earth orbit is very crowded, and they are adding more stuff. Starlink is adding more stuff to this densest part of orbit. And so far they haven't had any collisions, but how long will that continue? We don't know. We're at solar maximum right now, right? There was a great article that came out showing that Starlink basically lost control of their satellites for quite a while during that really amazing solar storm we had back in May of last year. Uh, and that could happen more, right? We're at peak now. There should be a couple more years of really high solar activity. So this is another thing that I'm worried about. If you get a collision in this really dense part of orbit, That makes a bunch of debris that's all traveling at several kilometers per second. That can take out more satellites. And then orbit becomes unusable, right? It's like a bullet field around the Earth. That's not what I want. Um, there's also a huge amount of pollution associated with launches. Rocket launches don't happen very often, so the pollution from rocket launches doesn't matter. But you can see how much the rocket launch frequency has increased over time. Um, all of the rocket launches, like the different types of fuel have different pollution byproducts. Many of them are greenhouse gases, many of them are ozone depleting. Um, uh, what's really significant is these very dry upper layers of the atmosphere. When you get water vapor up there, it behaves very differently than lower down. So water vapor at these high altitudes, even clean burning rocket fuels that only have water as a byproduct, that's actually really bad in the upper atmosphere also. So there's all these different products that are being deposited in the atmosphere. And it used to be not significant, but as we get more and more launches per year, very large launches like Starship, this becomes a big problem. Um, there's also these ionospheric holes that are caused when rockets launch. So it's almost like a fake aurora that happens, this red glow. And like it's clearly changing atmospheric chemistry. There's also been more of these noctilucent clouds, so very high altitude clouds. This is definitely a result of rockets. People are starting to study what changes are happening as a result of this. I mean, we can see that there are changes happening, but what is happening chemically, that is something that we don't know, and this experiment is just running. Um, Okay, but it gets even worse. So as we as I mentioned, the only way to dispose of satellites in low Earth orbit is to burn them up in Earth's atmosphere. So Starlink, so just conservatively, Starlink has 30,000 satellites at peak operation. Each of these satellites is 1,000 kilograms, so a ton. They have said that their satellites will have 5-year operational lifetimes. That means 16 tons of satellite will be burned up in the upper atmosphere every day. So that's a lot of metal being added to Earth's upper atmosphere. And yes, we have a huge amount of a huge mass of meteoroids, right? Shooting stars that naturally enter Earth's atmosphere every day. So it's 50 tons per day, but if you break down the chemical makeup of those meteoroids, it's very different than satellites, right? They're mostly rock, mostly silicates, right? Only 0.3 tons per day of aluminum comes in naturally. At peak, if Starlink are half aluminum, again, that's a conservative estimate. We don't know. They don't share that information. That's 8 tons of aluminum per day. So more than 25 times the natural infall rate of aluminum. So that's very different. Just over the last few days, so Jonathan McDowell has posted on various social media platforms that Starlink has been deorbiting 4 or 5 satellites per day, right? And these are some of the early ones, so they're not quite as big. They're maybe like 800 kilograms instead of 1,000. But yeah, that's all of that metal is just getting deposited in the atmosphere. And if it's not burning up completely, some of those pieces could make it to the ground. That's a lot. That's a lot of stuff that's just being thrown away in the atmosphere. So this throwaway idea, like, oh, build them fast and cheap and just replace them when they break. This is really harmful. This is an engineering challenge, right? Starlink and SpaceX have fantastic engineers that work for them. How do you make satellites last longer and use fewer of them? Um, So this reentry pollution is already measurable, right? So this is looking at the green, sorry, the pink is the number of satellites in orbit. You can see that hockey stick caused by Starlink. We're just now getting to the hockey stick in reentries as they hit their 5-year lifetimes, right? And already 10% of dust in the stratosphere is measured to have metal from rocket and satellite reentries. So we're already running this experiment. We don't know how that's going to change atmospheric chemistry. And then, yeah, whatever doesn't burn up makes it to the ground. And that's also obviously a very big problem. So, I complain a lot about Starlink, but they're just the first of many companies that have plans for thousands more satellites. You can look at Jonathan McDowell's website to get details of the orbits that they have requested. And then this is this really bright Blue Walker 3 satellite. They've launched 5 more now that are 4 times as big as this. That they are being measured by astronomers now. And they're not quite as bright as this first one, but they're still very, very bright. We absolutely need international regulation of satellites. There was a recent paper that showed that companies have plans for 1 million satellites, right? I'll just go out on a limb and say that you cannot have 1 million satellites in orbit safely. There's no way to do that. So yeah, we can't have this many satellites in orbit without severe environmental consequences and the risk of collisions increasing. So how do we safely use Earth's orbit now so that we can continue to use satellites, right? Like I just spent this entire talk talking about all the downsides of satellites, but satellites are incredibly useful, right? Some of you might be listening to this talk on satellite internet right now. And this is a useful resource, low Earth orbit. We use satellites for communication, for weather, for GPS, right? We need to protect our ability to continue to use orbit. So how do we prioritize the most beneficial satellites? Right now, the system is just whoever launches first gets to use orbit. And yeah, the Outer Space Treaty and Space Liability Convention need to be updated and enforced. And this all has to happen at the international level, which is incredibly slow. Meanwhile, SpaceX is launching 60 more satellites every few days. Okay, so that was a lot of bad, scary stuff in already what has been a kind of a bad, scary month for a lot of people. So what can you do as individuals? Like big, powerful corporations like SpaceX will respond only to 2 things: legislation, which is incredibly slow and probably won't happen right now in the US, and consumer pressure, right? They are a profit-driven private company, right? So if you have alternatives, don't use satellite internet, especially not something from low Earth orbit. There are higher altitude satellite internet options that are a little bit slower, but they're not as big of a problem because they cover a huge area with just 1 satellite or just a few satellites. The lower altitude requires more satellites, though I've never seen a justification for why 30,000 is needed. And if you do use Starlink internet, tell them that as a customer, you are concerned about the pollution and their safety practices in orbit, right? They will listen to you as a customer more than they will listen to me as an astronomer. Tell people what's happening. Most people have no idea what is happening in orbit right now. And talk to your local government representatives at all levels to support other ways of getting internet to people, right? So I live out on a farm. Rural internet is terrible, right? It's not reliable, it's expensive. I absolutely understand why people are jumping on Starlink. If I lived just a little bit farther from the city, that would be my only good option, right? So I totally understand that. Um, but there are other ways of getting internet to people. It just requires local governments to invest in infrastructure, which is really hard to get them to do. Um, you as an amateur astronomer group, I know you do amazing work showing people the night sky, doing public observing nights, getting kids out to dark sky places to see how beautiful the sky is. Keep doing that. That's so important. Most people don't know how fast the sky is changing due to satellites, and they don't care because they have no connection to the sky. So by continuing to do that volunteer work, you are doing a very important education job to help people have a connection to the sky, as we've had for as long as we've been human. And then go out and enjoy it yourself too, right? Make sure you get out there and see the beautiful stars, right? There are a lot of satellites, but there are times of year and times of night when you can't see them. So go out there and enjoy it. And so it's actually not up to date right now because I ran out of time, but I've started a website, Kessler Rebellion. The idea is that we are rebelling against Kessler syndrome, which is this runaway collision cascade in orbit. We don't want that to happen. We want orbit to stay safe and usable. So I have some information there, and a few letter writing campaigns that you can join in on if it interests you, and if they're still open. I need to go back and update it. Um, so yeah, so protect the sky. We absolutely need regulation of satellites. Astronomers are the ones who are noticing this change, right? Like there's so much that's way outside of astronomy, right? Like there's all this space law stuff and there's atmospheric chemistry stuff that like I didn't know anything about before this all happened. But astronomers are the ones who are noticing that this is a really big problem. So we're the ones who are speaking up first. Um, and yeah, that's a really wild story. A lot of scary things that are happening. No guilt if you don't aren't able to do any of these actions, but that's a list to choose from if you feel like you want to do something. So thanks for listening, and I'll be happy to answer a bunch of questions now.